In about 1992, we were given marching orders to go develop technology that could be used to monitor the Comprehensive Nuclear Test Ban Treaty. And the original specs were quite simple. They were looking for something about the size of a refrigerator, the power of a hairdryer, and the noise of a vacuum cleaner. So it was a big task. It was likened by some at the Department of Energy to the Manhattan Project itself, because although it wasn't as massive as the Manhattan Project, we had a long way to go, a short time, and a lot of pressure. In the case of Fukushima, on that given day that the earthquake occurred, I was supposed to get on a plane and fly to Japan to do an advanced site selection for placing a new station. And the phone rang. My wife gets up quite early, and the phone rang. My wife got it and came in and said, "I don't think you're going to Japan today." So there was this decision made to release the pressure in the pressure vessels in Fukushima. And that had to, as a result of that, they released a large portion of the xenon that was inside. And we knew there were other high temperature volatile things that would be coming. So here we said, okay, this will be here in a day or two. What do? Let's get samplers like the ones here around us. Let's get samplers all over the West Coast. Let's fly planes if we can. Actually, it turned out we couldn't. And let's make sure that we have our xenon system operating. We were doing forward atmospheric transport calculations and got the xenon actually a full day before we expected. So we were looking at the isotopes, trying to figure out what does all this mean. And I think it was about 2 in the morning in my office and said, you know, this couldn't be unless there was a complete loss of integrity of the fuel. And as soon as we said those words out loud, we realized, you know, we could have known this days ago from the first day if we had just thought about it. And so we're saying, well, our estimate is 100% of the xenon came out. My colleagues were saying, no, don't be so bold. And I said, okay, well, we're going to write that this was a serious loss of integrity. And we sent a report off. But this is why we've been working so hard for a decade, is that we needed to have these systems to measure whatever. And they're there and they're working. Everything's doing exactly what we said it would do. It was a very difficult time for all of us personally. We just felt like we were doing what we could do. The main utility of our information was to other people downwind to try to understand what was coming their way. We had a Fukushima Workshop in Vienna a couple of years ago. I organized it. And we had folks from the Philippines and other places, even Iceland, who were there saying, here's what we saw, here's what we tried to make of it, here's how we used the data that was coming from the CTBT. And they were saying, is there any way we could have a station in our own country? You know, we want more stations because we have a control system for nuclear activities in our own country, but we don't have insight or control over what goes on elsewhere upwind of us. So we want to have as much as we can get so that we can protect our population. It's fair to say that the RASA is playing an integral part in ensuring global security. The treaty is not yet in force, but some of the civilian applications of the treaty are also important. So whether it's predicting a tsunami using the seismic signals or understanding the magnitude of a civilian release of radioactive material, the RASA is important for that.